We are done with these particular topics that we discussed about the covalent bonding. We discussed about the position of the molecule due to their electronic configuration. We discussed about some of the basic properties. Then we discussed about the covalent bonding in large molecules. And we also discussed about the properties that they have the very weak intermolecular forces between them. Okay. So,
Sir,
yes, yes,
sir,
sir.
your voice is not clear.
Give me a minute. Give me
I also think it's low.
Okay, so we are discussing about the properties, and you both are saying that they have the low melting and boiling points. So it's good. We will write the point like this. They have low melting point and boiling point. What will be the reason behind this? What will be the reason?
Sir, because uh, the the attraction forces between the atoms are strong, but between the molecules they're weak.
That's good. That's good. Now the thing is like, let me give you the idea that when we were discussing about the ionic compounds, we are saying that the positive charge is attracting the negative charge ion. So that attraction is basically known as the ionic bond. When we are discussing about the covalent compounds, remember this thing. We say that this is a covalent compound. This is basically a molecule which contains the different types of atoms bonded together with the single, double, or triple covalent bond. This is another molecule which also contains the similar types of atoms with the similar types of bonds. These two are basically the neutral molecules. Okay. And neutral molecules also have some attraction between them. Neutral molecules also have some attraction between them. If I'm saying that I have a structure of ice, like if I say the oxygen is just attached with the two hydrogen atoms, this is a complete molecule we have. We have another oxygen which is attached with the two different hydrogens. This is another molecule of water in the solid state. And when I'm just saying that I have to melt the solid, what do you think? Will the bond between the hydrogen and oxygen will break or not? Or just molecule number one and molecule number two, they just move apart from each other? What will happen? The bond will break or the molecule will move apart from each other? They move apart from each other. So it means
Yes,
that
only
they
the
are just
molecule.
colliding with each other. They are just in a position that they are near to each other. So it means that there must be a force in between them. That force is basically known as the intermolecular force. Or we say another word for this force is van der Waals force. Van der Waals force. I got the name here. Van der Waals force. What is intermolecular or van der Waals force? Van der Waals basically was the one who discovered this force at very first. Intermolecular force is the force between the neutral molecules, the attraction between the neutral molecules. This molecule is overall neutral, this molecule is overall neutral, and the attraction between these two neutral molecules is known as the intermolecular force. Okay, and in the comparison of this, if I'm saying that this is the covalent bond, and if I just see the ionic bond, we say that there is no intermolecular force because there is an attraction between all the positive and negative charged ions. That attraction is basically known as the ionic bond. So what do you think? Which attraction is strong? The electrostatic attraction between the positive negative ions or the intermolecular force between the molecules? Ammar, which force is strong?
Between ions.
Between the ions, the electrostatic attraction between the ions is very much strong. That is why we said that the ionic compounds have very high melting and boiling points. Is this is clear? So we are saying that they have the low melting and boiling points for covalent compounds due to the weak intermolecular forces between the molecules. The second one, basically the point which I am giving you right now is not basically a particular property, but when we are considering the ionic compounds, we say that most of the ionic compounds are solid. If I say that 95% of the ionic compounds at room temperature are solid in state. But when we are discussing about the covalent compounds, there is no regular parameter, there is no regular pathway for explaining the state, because the covalent compounds normally found in the solid, like the we say the solid, the liquid, and gas. In these three states, the covalent compounds found in these three states, the solid, liquid, and gas, majority of them are the gases, and some are liquids, and very few are the solids on the room temperature. Are you getting my point, boys?
Yes, sir.
Okay. The melting and boiling points are weak due to the reason of the weak intermolecular, melting and boiling points are low due to the reason they have weak intermolecular forces between them. What if I say about the conductivity? What do you think about conductivity? Saif, what do you think? Will these compounds be a conductor? Will they conduct electricity from them or not? Saif, will the covalent compounds conduct electricity or not? Amar, am I audible, bete?
Yes, sir.
शेफ कहाँ चले गए ये क्लास छोड़ के चले जाते हैं ना ये दिस इज नॉट गुड अच्छा टेल मी अमर दैट will these compounds conduct electricity or not
No, sir, he is in class.
yes
No, sir, he is in the class, sir. And for conductivity, I don't think they will do any conductivity because their forces are weak.
okay now let's see the reason as well as you said that they are not the good conductors we will say that they do not conduct electric current what we say the electricity when molten or dissolved in water. What will be the reason behind this? Saif, are you there? Okay, tell me, Amar, what will be the reason behind this that they are not the good conductors of electric current?
They're weak electrostatic forces.
No, because
It is the opposite for ionic compounds, right?
no, not we say that it is an opposite of an ionic compound, but they all have the different criteria. They all have the different ways. Because they do not contain ions. They do not contain ions. You remember that for the electric current, for the passing of electric current, we need ions. We need the positive and negative pathways. Is this clear? They are the bad conductors, basically. Na? Somehow we say that they are the non-conductors of electric current. They are the non-conductors of electric current. Na? Why they are the non-conductors? Because they do not contain ions in them. They do not contain ions in them. Is this clear? If we discuss
Okay, sir,
about
so they can't conduct electricity in any state, right? solid,
They do
liquid, or
not
gas.
yes, they do not conduct electricity in any of the state, but somehow it's a very rare scene. Na? We say that we are going for the majority. We are going for the majority, but in the minority, they can conduct. Some of the covalent compounds are the one they can conduct electricity. Like if I gave you the example of water, it's a very basic example of the substances of the covalent compounds. Like they conduct electricity. Water can conduct electricity. How it can conduct electricity, Amar? Can you please tell me? The reason is that water on its own, if I am saying that I have a pure water, na, that pure water which doesn't contains any of the nutrients, any of the minerals in it, it will not conduct electricity. But when I am saying that I have a normal tap water, it contains some minerals in it, it contains some salts in it, or we say that any of the ionic compound. So when I say that I will just add salt, NaCl in it, we know that the Na will generate the positive ion and Cl will generate the negative ion when it dissolves in water. And due to this, when the water molecule sees them, the water molecule will also become the H positive and OH negative. Am I clear here? The water will become
Okay,
H
sir.
positive and OH negative by seeing these two ions. Before seeing them, water is a normal covalent compounds like the hydrogen and oxygen are just connected with each other.
It will form ionic compound, the covalent compound.
What Amar?
So the water will form an ionic compound or a covalent
Water will
compound.
turn ionic compound. Let me give you the idea that we have a parameter,
Okay.
like we say that some of the compounds are pure covalent, some of the compounds are pure ionic, and very few of the compounds we have which are in between this. Like we have the ionic, we have the covalent, and some of the compounds are like here. They are partially ionic and partially covalent. These are the major culprits we have. They have the covalent bond and they can conduct the electric current from them. Am I clear here, boys?
So tap water is one of them.
What, Ammar?
So tap water is one of them, right? The
Yes,
partial
water is one of
ones.
them. Water is one of them, basically.
And yeah, pure water is not. Only tap
Pure water is not the
covalent
one, because when I'm saying
Yes.
the pure water, na, water is like I give you the example. Let's say that एक क्लास है, उस क्लास के अंदर जो है बहुत सारे बच्चे हैं, सही है, and I have a student in that class, और वो बहुत अच्छा बच्चा है, बहुत प्यारा बच्चा है, वो कोई शरारत नहीं करता और वो कोई इस तरीके की बात नहीं करता, लेकिन उसके ना कुछ दोस्त बन गए जो बुरे थे। अच्छा, अब उसने जब उन बुरे दोस्तों को देखा ना, जो हमें कहा जाता है ना, बड़े कहते हैं हमेशा कि दोस्तों की सोबत बहुत मैटर करती है, तो जब उसने उन दोस्तों को देखा ना, वो बुरे काम कर रहे थे, वो गंदे बच्चे थे, वो शोर शराबा कर रहे थे, इसके अंदर जो थोड़ा सा वो एक बुराई का आंसर था ना, वो जाग गया। बात समझ रहे हैं आप मेरी? वो जाग गया इनके साथ मिलके, लेकिन वो जब तक इनसे नहीं मिला था तब तक वो बहुत अच्छा बच्चा था। अब आपको समझ में आई मेरी कहानी जो मैं बताना चाह रहा हूँ?
Yes, sir.
So this is the thing that we have water in a neutral. When the water is in the pure form, we say that water will not conduct electric current from it. But when I say that water has some minerals in it, water has some salts in it, water has some acid or base like the ionic substances in it, water will start conducting electric current and then also generate the positive and negative ions. So when we are just saying about the solubility, or we're discussing about the solubility, so we know that if we are considering about the covalent compounds, so we say that these compounds are soluble in what, Amar? Polar or non-polar? Will the covalent
Polar?
compounds soluble in polar or non-polar?
Polar.
Non-polar. Soluble in, because polar are the ones which will generate ions, and when we are considering the properties, so we are considering on the majority basis, na? So majority are the non-polar ones. Covalent compounds are basically the ones which will not generate ions on the majority basis.
Okay, sir.
Okay. So is this thing clear? Are you writing with me, Ammar, or not?
Sir, I'm writing.
Okay. So write this thing. Okay, write this thing and do let me know, then we'll start discussion.
Yes, done, sir.
Okay, give me a minute. Let's see that we are done with the properties, the melting point, boiling point, conductivity, and the solubility. Let's mark the topics we are done with.
Sir,
Yes, Saif, where have you been, man?
yes, sir.
Okay, sir. So now let's see that we will mark the topics we are done with. We are done with definition. We are done with molecular structures. We are done with the properties, the poor conductivity and low melting boiling points. We also done with the dot and cross diagrams or not?
Yes, we are.
Okay.
Yes, sir.
So
We're done with
I
that.
gave you a homework of CH3OH. Are you done with this?
Yes, sir.
Let me draw this thing for you so that you can get
Yes,
the idea that were you right or not. It is the CH3. Like I say that it is the OH, as you are saying that this is OH and this complete molecule is basically the CH3. So now we have here, which is the CH3OH. It is known as methyl alcohol. Or we say that it is methanol. Is this clear?
Yes, sir.
Okay. Okay,
Yes.
boys. So we're done with the properties as well. Now we have to go for the giant molecular structures. The giant molecular structures we have here. Okay. Now let's see that they are saying that describe the giant covalent structure of graphite and diamond. Relate the structures and bonding of graphite and diamond to their uses. Describe the giant structure of silicon dioxide. Describe the similarity in properties between the diamond silicon oxide related to their structure. Acha, can you both of them? Can you both of you just tell me that what is diamond and what is graphite chemically? On the atomic level, what are these elements? Basically, these are the substances, no? What is diamond and graphite, boys? Tell me. Do you know about the diamond and graphite?
Yes.
Okay. Let's see. At very first, we will discuss a property, and that property is somehow relatable to this topic. And that property, that particular thing is known as allotropy. Have you ever heard this word, allotropy? Allotropy. You know anything about this?
No.
Okay. Let's see that the existence of an element in more than one physical form Physical form means not like the physical state, like the solid, liquid, or gas. It is basically the physical form. In the same physical state. Is known as allotropy. Different forms are known as allotropic modifications or allotropes. It's kind of a very tough in these words. I'll give you the very simple words for get the understanding of this topic. Like if I say same element, same state, different forms, different physical properties, same chemical properties. This is basically a complete explanation for the allotropic forms. For the allotropic forms, like the allotropic modifications or allotropes. We have a simple element, we have a same element, like if I'm discussing about the carbon, we say that carbon. In the same state, like solid, different forms, this, I gave you the diagram regarding the structure, no? So that you will understand properly. Different forms, they have the different physical property, like if I say hardest natural substance, easy to break, or we say a simple word here, it is brittle. Found in different colors, only grayish black, melting point about 3000 degrees Celsius, melting point about 3500 degrees Celsius. Okay, so they have the different physical properties. Am I going good or not? They have the different physical properties, like the first substance we have here is basically the hardest natural substance known to one. The second substance we have here is the brittle one. We can easily break it into the pieces. That substance, and the first one we can found it in the different colors, like the green, red, blue, or the colorless, or we say the yellow one as well. And the second substance we can only found in the grayish black color. The melting point of the first substance is the 3000 degrees Celsius. The melting point of the second substance is almost about 3500 degrees Celsius. But they all are same. They all are similar in the chemical properties. Like if I just burn the substance, I'll get the carbon dioxide. If I burn this substance, I will get the carbon dioxide. Is this clear, boys? Am I clear?
Yes, sir.
Okay. So what are the names of these substances? We say that this is, mere bache, is the diamond, and this is graphite. And as you are seeing here that they both have the covalent bonds between them. We'll see the structure in a very giant picture as well, as because they are the giant structures, no? They are the giant covalent structures. They all have the covalent bonds. Let me add a very great physical property here. Non-conductor, and it is a good conductor. Diamonds are very costly and it's not relatable to the male ones. So मैं ये नहीं कहूँगा कि डायमंड आपने देखा है, आपने यूज किया है, आपके पास है. मैं ये जरूर कहूँगा ग्रेफाइट. ग्रेफाइट वी हैव अ पेंसिल ना, हमारी जो पेंसिल की निब होती है, इट्स मेड अप ऑफ द लेड पेंसिल्स ना, दे आर नोन एज लेड पेंसिल. तो लेड ग्रेफाइट से बनती हैं ये. इट कंटेन्स लेड एज वेल एज ग्रेफाइट इन इट. सो आर यू एबल टू ब्रेक दैट पेंसिल्स निब और नॉट? क्या वो पेंसिल की निब आप अपने हाथ से तोड़ सकते हैं या नहीं?
Yes.
आप बहुत इजीली तोड़ सकते हैं. इट्स ब्रिटल. वो ग्रेइश कलर में ही होता है, बहुत हाई मेल्टिंग पॉइंट, और इट्स अ गुड कंडक्टर ऑफ इलेक्ट्रिसिटी. बट डायमंड इज अ नॉन कंडक्टर. इट नेवर कंडक्ट्स इलेक्ट्रिक करंट फ्रॉम इट ना. We say that when it is pure, when diamond is pure, it is transparent na? It is transparent when diamond is pure. But we can find the diamonds in the different colors like the green, blue, yellow or black. Black diamond is very common because it is used in the drills as well. तो ये सारी चीजें हैं, ये सारे करेक्टरिस्टिक्स हैं, एंड दीज बोथ आर बेसिकली द एलोट्रोपिक फॉर्म्स ऑफ कार्बन. लेट्स से कार्बन इज एक ऐसा एलिमेंट है, आई पर्सनली लव कार्बन. द रीजन इज दैट कि कार्बन एक ऐसा एलिमेंट है, किसी भी एलिमेंट की जितनी फॉर्म्स पाई जा सकती है ना, कार्बन की वो सारी फॉर्म्स पाई जाती है. An element can be easily found in the isotopic form. Carbon has some isotopic form. An element can be found in the crystalline form. Carbon has crystalline forms. An element can be found in the allotropic forms. Carbon has allotropic forms. An element can be found in the amorphous forms. Carbon has some amorphous forms. So carbon is every form. No? Carbon is a very, very abundant element in our universe, abundant element in our world as well, that we have carbon in most of the materials we are using. Okay? So यहीं से हम start करेंगे giant crystal structures को इंशाल्लाह अज़ीज in our next class. If there is any query, you can ask me on WhatsApp, boys. Okay? सही है? Ammar, Saif.
Yes, sir.
Okay. So इंशाल्लाह मुलाकात करते हैं. अस्सलाम वालेकुम.